Alright, y'all, we're going to get into this. So this is going to be your video preparing for the first common assessment. We're going to be talking about the first two topics of the school year. So that's topic 1, solving equations and inequalities, and then topic 2, solving linear equations. I'm going to try something a little different in this video. So for each of the questions that we talk about, I'm going to kind of highlight the main concepts that the question requires you to know and understand in order to answer the question correctly. And hopefully, if you're doing some additional studying on your own, you'll be able to take that information about what topics or what concepts are at question and be able to do some more brushing up on those in addition to this video. So without further ado, I'm going to slide over and get us right into question number 1. So number 1 here asks us to match each equation with one of the graphs given and then to identify the slope of each line. And so we've got these 3 different graphs, and we're supposed to match them to each of these 3 equations. Now, whenever you've got to this identification kind of question, you're going to want to know a couple of things. First, I need to understand slope. And then after that, y-intercept is going to be helpful to know. Okay, so we're looking for the slope and the y-intercept, and the reason that we can tell that is the case is because each of these equations is given to us in this form, which looks like this. And we call that our slope-intercept form. Okay. Slope obviously stands for slope, and intercept is specifically the y-intercept, not the x. Okay, so each of these equations is given to us in slope-intercept form, and so we need to identify the slope and the y-intercept for each of these lines. Okay, so let me erase all that. And so if we take a look at the lines that we are given here, A, for example, I'm going to zoom in, looks like it has this y-intercept right here in between 9 and 8. It's a little fuzzy on this image here, or 9 and 7, but you can see that that is a y-intercept of 8. So that's going to be at the point 0, 8. Okay? And so based on that alone and looking at each of our different equations, if these are all in slope-intercept form, then that number, that constant at the end, is going to be what represents the y-intercept. We see at this first one it's 6, at the second one it's -8, and so this third graph is the only option we have for a matching y-intercept, and we see that, yes, that is at +8. So this one matches with graph number A, or graph letter A. For B here, we're looking at the y-intercept. We're seeing that now it's at that number between 7 and 5, 6. And given the two choices we have, we see the first one is a match. So process of elimination tells us this one must be C, but we can be certain because we've got these numbers below the x-axis, and the graph's kind of is labeled here, but it doesn't really matter because we see it crosses at that 8 below the x-axis. That must be -8. And so graph C is that one in the middle. Now, what if it came to it and we really couldn't tell based on just the y-intercept alone? If that were the case, we could use the slope to help differentiate these lines, which I'm sure was the intention when they wrote these questions, but we want to pay attention to whatever make the question as easy as possible for us. Okay? So if we needed to use the slope to help differentiate, remember all slope is a change in y over a change in x. And on a graph, it's especially easy to see because we can count it. So if I look at this first graph here, to get from this point down here, the x-intercept, to this point up here, the y-intercept, that's a change in y of going from 0 all the way up to 8. So our change in y is 8. And from there, all the way to 0 on the x-axis. So it's going from -6 to 0. That's a change of 6 on the x-axis. And 8 over 6, if we were to simplify it, would get us 4 over 3. Okay? Now that matches the slope that we're seeing here in the equation we already matched with that graph, but that's just another way to kind of identify that that's the correct slope. If I were to do that again, well, let's say for a negative graph this time, we look at this one, B, where we have our y-intercept there at 6 and our x-intercept there at 8. The change in y there is going to be down 6 times. And then to the right, 8 times. So down 6, to the right 8. And a slope of -6 over 8 simplifies to -4 over, or sorry, -3 over 4, which, as you see there, matches the slope we have for, again, the equation we already matched to that graph. So no matter what method we use or what feature of the graphs we use, and sometimes we'll need to use both, but here we got lucky because the y-intercepts for these are all distinct. So BCA works as an answer choice. Number 2 asks us to describe key features of the linear function presented in the table. And so what we're going to do is identify, again, the slope and the y-intercept. Now, remember that when we're saying slope, all that means is we're looking for a change in y over a change in x. And for the y-intercept, we're looking for the place on our graph where we have an x value of 0. Okay? That's also called b in slope-intercept form. All right? And so, yeah, we're looking for those 2 key features of this linear function. Now, to start with the slope, because I know this is a linear function, I know that slope is going to be the same between any 2 points on our line. No matter which 2 points we pick, if we compare a change in y values to a change in x values, we should get the same answer every time. So I'm going to look at my y-axis here at the beginning. So I'm going to pick these 2 points, -4, at least the thinner one. So -3, 4 is going to be the first point I choose. And then we'll go to the next one, -2, 7 to keep it easy. Okay? And I'm going to look for what my change in y is. So I go from 4 on the y-axis to 7. That's a change of adding 3. And over here on the x, I'm going from -3 to -2. That's a change of adding 1. So if our slope is adding 3 over adding 1, then our slope must be +3. Now, if we look for the y-intercept, again, we're looking for the place where our x value is 0, all right? And so if we're looking all on the x column of this table, we see right here we see that when x is 0, y is 13. And so that's going to be our y-intercept, 0, 13. Okay, so not much to do there outside of calculate that slope, which we can do like that. Also remember that slope is calculated most generally through the slope formula. And all that is y2 minus y1 over x2 minus x1. And make sure that you are consistent in your labeling of the points. If you're saying, let's say we plugged these 2 values we had in here, -3, 4 and -2, 7. If I was labeling those to plug those into the slope formula, I want to be consistent in remembering -3 is my x1 and 4 is my y1. And over here, -2 is our x1 and 7 is our y. Sorry, x2 is what that should say. Let me fix that. Yeah, don't do what I just did. x2 and y2. And I also want you to remember that disregard, or I shouldn't say disregard, but pay attention to what numbers are negative in these situations, okay? If I'm plugging these into the slope formula, let's go down a little bit, it would look like m equals y, I'm just mislabeling that, I should say y2. That should look like 7 minus my y1 is 4 over x2, which is -2, minus, and then my x1 would be -3. And we don't worry about that double negative because we understand that simplifies out to be addition. So 7 minus 4 is 3, and -2 minus -3 is -2 plus 3, and that is +1. Okay? So whether you just counted it from the table or you plugged it into the slope formula, you would still end up with that slope of 3 over 1, which is the same thing as saying 3. All right. Number 3 gives us some application to work with. So it says, at a carnival, hamburgers sell for $3 each and hot dogs sell for $1.50 each. The equation 3x plus 1.5y equals 30. And describes the number of hamburgers and hot dogs a family can buy with $30. So we see that that $30 there is the 30 at the end of our equation. It's our sum. We also see the $3 is attached to the x here, and the $1.50 is attached to the y here. Okay, so each portion of information in this problem is representative of a portion of our graph and our equation. And so what I also want you to take note of is that x in this situation, because it's attached to the $3, that must be representative of our hamburgers, right? Because we know hamburgers sell for $3 each, and each indicates a coefficient most often. And because hot dogs sell for $1.50 each, hot dogs must be our y. For the same reason. Usually, each indicates coefficients. Okay? So using that information, we're going to do two things. The first of which is graph the function, and then the second of this is going to be identifying the y-intercept and determining what it represents in the context of the problem. So to start, I'm going to go ahead and take our equation. We're going to work with it a little bit. So it says 3x plus 1.5y equals 30, where x equals the hamburgers and y equals the hot dogs. Cool. So we're going to go ahead and we're going to figure out how to make this equation work in terms of graphing it. And when we have an equation that's given to us in this standard form, I want you to think about two things. The x-intercept, which is where y equals 0, and the y-intercept, which is where x equals 0. If we understand that we need 2 points to find the graph of a line, then the x-intercept and the y-intercept, having both of those pieces of information, is enough to graph, right? Because those are each 1 point, right? So we're going to start with the x-intercept. And maybe I should flip around how I do this. 3x plus 1.5. And we're going to replace the y value with a 0. Okay? Multiplying by 0 is going to get rid of that 1.5. And so now we just have 3x equals 30. And dividing both of those sides of the equation by 3 will get us x equals 10. So for one part of this, we know that our x-intercept is at 10. So 10 on the x-axis is where our line intersects. Now we're going to do the same thing with the y-intercept. And so we're going to do the same exact thing. But this time, we're plugging in the 0 in the x's place instead of the y. Again, multiplying something by 3 or by 0 is going to cancel it out. We have 1.5y. 1.5y equals 30. We just divide both sides by 1.5. And we should end up with y is equal to 20. So we now have our two intercepts. X is going to intersect, or the graph is going to intersect the x-axis at 10. The graph is going to intersect the y-axis at 20, and we have enough information to graph. So I'll plot my first point here, x-intercept at 10. And our second point up here, y-intercept at 20. All right. And I'm going to go ahead and finish off by giving us a nice little graph. Do I have like a purple I could use here? Yeah, let's do that. And we're just going to connect them. Ooh, not like that though. A little something like that. And that's going to represent our line. So part A is done. We've graphed it. Now we're going to consider the options here. It asks us to identify the y-intercept. So that is this portion here of the graph. And if we're looking at that y-intercept, that is, at this point, 0 on the x-axis, 20 on the y-axis. Remembering that x represented the hamburgers. And the y represented the hot dogs. Okay? So then what does it mean if we're looking at a point where there's 0x and 20y? That's 0 hamburgers and that's 20 hot dogs. And so we look at our answer choices. It says the y-intercept is 10, which we know just isn't true. So we can eliminate answer choices A and D. That leaves us with B and C. The y-intercept is 20 in both of these situations, and it says it represents the number of hot dogs and hamburgers the family can buy with $30. C says the y-intercept is 20 and represents the number of hot dogs the family buy with $30 if they don't buy any hamburgers. Because we know that the x value here, hamburgers, is 0, we know that has to be the correct answer. Because we're buying no hamburgers and 20 hot dogs. And so our answer is C. All right, more application for us here at number 4. It says, Marianne brought $30 to spend at her family or her favorite farmer's market and craft show. She purchased a t-shirt for $7.50 at the tie-dye station and now wants to buy some locally grown plants for $2.75 each. They ask us to write an inequality to find the possible number of plants Marianne can buy. We're going to start there. So whenever we're approaching these word problems and we have to write the equations ourselves, we want to start by defining our variable here. And the thing that we don't know, as they tell us in part A, is the possible number of plants that Marianne can buy. So we're going to have X here, the number of plants. It's also helpful, these inequalities, to figure out what your total is going to be. And so in this situation, if we know she brought $30 to spend here, she can't spend more than that. So $30 is going to be our total. Now we also want to be looking for constants and coefficients. And sometimes it's going to be easier said than done when given in a word problem. Sometimes we just kind of have to figure it out as we go along. But we want to look for any keys or any clues that they might give us as to which numbers are which. So number 4 says, we've got this $30 to spend. She purchased a t-shirt for $7.50. And that doesn't look like it's a recurring charge, right? It's just one t-shirt. So I'm inclined to say that the cost of the t-shirt is $7.50. That's going to be our constant. We're only paying for the one t-shirt. And so it's $7.50 one time. And now wants to buy some locally grown plants for $2.75 each. Now, as we talked about previously, that word each is what usually indicates that we're looking at a coefficient. And we know because it's in conversation with the number of plants she's buying, that must be our coefficient. Okay? So there's going to be a relationship between the things that we're buying and the amount of money we have to buy it. And it's going to look like this. $7.50 plus, I'll use a thinner marker there, plus $2.75. And because it's a coefficient, our variable has to go on. Now the question is, this is all being related to that 30. But in what way? Because it asks us to write an inequality, so equal sign doesn't cut it here. If we're thinking about what the problem tells us, and we know that Marianne has $30, we know that she's allowed to spend less than that, right? And so we can say that the amount she's spending represented by this portion of our relationship. If we know that the amount of money we spend is allowed to be less than $30, right? Because she's allowed to go to the craft show and spend less than $30. She doesn't have to spend all her money. But we also understand that she can spend exactly $30, right? She can spend all the money she brought. She can't spend any more than she has because otherwise she doesn't have enough to pay for it. So then this is going to be the inequality that represents our situation here. $7.50 plus $2.75 for every plant has to be less than or equal to 30. Now part B asks us to solve the inequality to tell how many plants she can buy. So we're going to do exactly that. So our inequality said $7.50 plus $2.75 x is less than or equal to 30. We're going to start by drawing our line under the inequality sign. And we're going to get rid of that $7.50 first. Remember that you want to get rid of any terms you're not concerned with before you worry about the term that you do care about. So we're going to subtract $7.50 from both sides. Okay. That's going to cancel out with that. And so now you have $2.75x. Over on the right side, 30 minus $7.50 is going to get you, what is that, $22.50? And so now we have the term that we care about, and we have to do some division. So we're going to divide both sides with that $2.75. That cancels out, and now we're left with x by itself on the left here. Because we didn't divide both sides by a negative number, we don't have to worry about flipping the signs for this inequality. And if we do some division, 2250 divided by 275 is going to get us about 8.18, and that's going to be repeating. So then the question is, Well, how do we know how many plants she can buy, right? Because 8.18 doesn't really seem like a reasonable answer. We can't buy 18 hundredths of a plant. So we have to think about this logically. If we know we can buy 8 and some change, and we're thinking about the fact that our answer has to be a whole number, then it only makes sense that we can buy anything up to 8 plants, right? If we tried to round up to 9 plants, we wouldn't have enough money to pay for it. So 8 has to be our answer here. Now, if we want to check that, the easiest way to do that is to take that value for x and plug it back into the equation. So 750 plus 275. We're going to plug in that 8 we got for the solution is less than or equal to $30. We're going to go ahead and we're going to... Actually, we don't need to draw our line here because we're not solving. So the first one we can do is 275 times 8. And if we type that into our calculator, we end up with 22. We're still adding at 750. We're seeing if that's less than or equal to 30. 22 times 750 is going to get us 2950. And that makes our equation say a true statement. That is less than 30. And that is as close as we can get to 30. Because if we try to buy another plant, that's going to put us over the amount that Marianne has. So we know that that is absolutely correct. So 8 plants it is. All right. Number 5 here asks us to write and solve an inequality to determine the number of points based in the situation. So it says Jorge is playing a game in a 3-game or is playing a 3-game basketball tournament. He scored 24 points in the first game, 9 points less than that in the second game. If he averages at least 20 points for all 3 games, he'll receive the MVP trophy. We got to write and solve an inequality to determine the number of points Jorge needs to score in the 3rd game to receive the trophy. Okay? And so that's going to be our variable, right? We're using the variable to represent the number of points Jorge needs to score. If we're thinking for a total, we know that he needs to average at least 20. They kind of give us the hint there with the at least, what the total is going to be. So yeah, our total needs to be 20. Now, in terms of other pieces of information, we know that he scored 24 points in the first game. He scored 9 points less in the second game. And so if we're looking for our constants, it doesn't look like we have an each, every, per here. So constants are what we're dealing with. We know we got 24. And 9 points less than that would give us 15. So we scored 15 points in the second game. And so if we're writing our inequality, it should look a little something like this. 24 points in the first game, plus 15 points in the second game, plus X points in the third game. Now we're talking about a situation where he needs at least 20 points. So he's okay with and probably prefers to score more, just to make sure he's a shoo-in for this MVP. So at least suggest we use a greater than or equal to sign, and then 20. Now this is almost done, except for this word they use for us here, which is average, right? So we're saying we need to average at least 20 points in this 3-game basketball tournament. So that's 20 points per game on average. And hopefully you'll remember that all averages, I'll write this over to the side here. When we say average, what we mean is the sum of all the data points we're working with this. In this case, the scores from each of his games is going to be the data points we're working with. So the sum of all of the data points, the sum of all of his scores in each game, and we're dividing that by the number of points. Or in this case, the number of games. All right? So that's a definition for average. We're going to take that, we're going to apply it to our situation here. 24 plus 15 plus X would give us the total score across all three of the games. But to average it, we need to divide it by the number of games that he's playing, which is 3. And so that's going to be the inequality that we can use to represent the scenario. So I'll rewrite that up here. 24 plus 15 plus X, all divided by 3, needs to be greater than or equal to 20. And now that we've written it, they want us again to solve it to give it the exact answer, so we're going to do that. Now again, all we're going to do is draw our line. And here we can start by simplifying these two like terms, 24 and 15, which is going to come together to get us 39. With that X still being added on. Now, because we're dividing by that 3, and that's affecting the most there, and it's affecting everything on top, including our X, what we want to do is multiply both sides by 3. On the left, multiplying by the 3 is going to cancel the 3's out. And so you've got 39x, or 39 plus x. And that's going to be greater than or equal to 20 times 3 is 60. Okay? Now to finish off, all we have to do is subtract 39 from both sides. And that's going to leave us with x is greater than or equal to 21. So that is going to be our solution. Jorge needs to score at least 21 points. He's allowed to score more, obviously, but 21 is going to guarantee that he gets that average of 20 points a game. All right. Now we're into some literal equations. So this one tells us we want to find the volume V of a cone that is given by the formula V equals 1/3 pi r squared h. They ask us to solve the formula to find the radius, which they call r. So I'm going to copy down that formula down here. We're going to draw our line, just as we always do when we're solving. And we're going to pay attention to r. Because ultimately, that's what we want by itself. Now, the first thing we can kind of focus on is the 1/3, right? Because that's the fraction, that's the thing that might give you the most difficulty in trying to figure out how you would work with this. But I want you to remember that we can get rid of a fraction completely, right? We don't just end up with a whole number. We get rid of it, kind of like if we were canceling out anything else. If we multiply by its reciprocal. And what that means is the flip, the inverse. So if I were to look for the flip, the inverse of 1/3, that is 3/1, which is the same thing as saying 3. So multiplying both sides of this equation by 3 is going to get rid of that fraction, and we're not going to have to worry about it anymore. So let's do that. Now 3 times the 1/3, like we said, it cancels out. So we're left with pi r squared h. Over here on the left, we've got 3 times v, which is just 3v. Now we're going to look at these guys, the pi and the h, because those are being multiplied to the r squared. And if we're trying to get r by itself, we got to handle those first. Now, if they're being multiplied, then the best way to handle them is to just go outright. I'm going to continue that line there. We're going to divide everything by pi and h. Because multiplication cancels out, or division cancels out multiplication. So on the right side, the pi's cancel out, the h's cancel out, and you are left with r squared. Over here on the left, we got 3v, and that's being divided by pi and h. Now the last thing to consider is that we've got this, hold on one sec, there we go, square root, or the square, right? R squared is a situation. We got to get the r by itself. If addition and subtraction are inverses, they cancel each other out, and the same is true of multiplication and division, then square should also have its inverse operation, and that is square root. So to finish off, we're going to take the square root of both sides. Square root of r squared is just going to be r. And over here on the left, square root of 3v over pi h. There's no meaningful way to simplify that, so we're just going to write it all out. Square root 3v over pi h. And so now we have an answer. Let me make that h look a little more h-y. Better. And so we have an answer for this literal equation. And if we look at our answer choices, the closest looking one is B. Just make sure the other one was good. Yeah, we wrote that in. All right, cool. So yeah, B is our answer choice here. All right. So now we're talking about Tamara. It says Tamara is reading a 200-page book. She reads 4 pages every 5 minutes. The number of pages Tamara has left to read after X minutes is represented by the equation f of x is equal to 200 minus 4 over 5x. Okay? So we can see that this equation is written negatively here, right? Where 200 is the initial value. That's how many pages she has left to read at the beginning. And then the negative 4/5 x, or specifically the negative 4/5, is representative of this situation here. She has 4 pages of read every 5 minutes. And so that's our slow. That's the amount of pages she knocks out over time. So they ask us a couple of things, the first of which is to graph the function. So we'll go ahead and do that. This is formatted kind of strangely here, so I'm going to try my best to make it out. I don't know why this is reading like this, but maybe the best thing to do here is to just kind of make a quick labeling system ourselves. I think what we can do here is, let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90. Let's go 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. What if we went like 15? 15, 30, 45, 60, 75, 90, 105, 120. We could do... that's not going to get us anywhere either. All right, so how about we do this by 20s? Seems easy enough. Just a little annoying because we don't use the entire graph, but it's fine. So this graph's going to go up by 20s. So this is 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280. And we're going to leave it at that, all right? So that makeshift labeling is going to be what we do there. You can do the same thing on your papers. We're going to take it from there. So it says that our y-intercept is 200 according to the information in the question, right? We've got this fx equals 200 minus 4/5 x. And again, that 200 is the initial value in the situation, which we call the y-intercept. So we can plot it at 200, or we've marked as 200 on the y-axis. Okay? And now we have to progress by the slope of -4/5, which is a little more challenging than it would seem because our graph here does not have regular intervals. So we're going to have to do some math to make it work on our graph. So if I think about -4/5, okay, using the increments we have here, on the y-axis, we labeled by 20s. On the x-axis, you see us labeling by 50s, okay? So that means my change in y over change in x has to have the same relationship. And so the easiest thing I can see to do that is, let's say that we are going in increments of 20 on the y-axis, so -20. We got to figure out how much of a jump on the x-axis that's going to be. And to do that, we're going to look at the y value we have there, and we're going to see what do we multiply to get from -4 to -20. And hopefully you recognize that's times 5. Okay? And so if we're multiplying the top by 5 to maintain the equation or the fraction, we're going to multiply the bottom by 5 as well. And 5 times 5 gets us 25. So we see that if we jump down 20 on the y-axis, we got to go over 25 on the x-axis. But that doesn't work super well for us either because, like we said, our x-axis counts in 50s. But I also know that 25 is half of 50. So there's one more change we can make to this fraction to make this really make sense. Again, we can multiply the top and the bottom. I know that I want to get my x value to be 50. And we can do that if we multiply by 2. So we can do the same thing with the top to maintain the relationship, and we end up with -40 over 50. Okay? So every time we jump down 40, or in the case of our y-axis, 2 values, we jump over 50 on the x-axis, or 1 x value. So this functionally looks like going down twice and to the right once on our graph, but these are the values we're working with. Also want to point out the way easier way to do this, just look at what happens based on what we got to from where we came from. We just added a 0 to the top and the bottom of our fraction here. So I didn't have to do all that multiplication, but we'll work with it. So to get to the next point on this graph, we're going to jump down 40 values, or 2 spaces, and to the right once. And we can do that again, and again, and again, and again. And now we have an accurate line representing the situation here, which I'm going to do my best to freehand. Not the best, but you get the idea. So then it says, what is the y-intercept? We said that up top here, that is at 200. What is the x-intercept? We see based on our graph here that is at 250. And then they ask us, what does the x-intercept represent in the situation? So the x-intercept here is where our y value is 0. So that is 250 on the x-axis and 0 on the y-axis. The x-axis represents the number of minutes, and the y-axis represents the number of pages that remain. So what this point tells us is that at 250 minutes, we have 0 pages left to read, but otherwise we finished the book. And the answer choice that best reflects that is C. The x-intercept represents the number of minutes it takes Tamara to finish reading the 200-page book. A little typo there, but will live. So that is that. All right, number 8. It says, write the equation of the line that passes through the point 2, 3 and is perpendicular to y equals 2x plus 7. All right. So this one is one of our most recent topics. And remember when we say perpendicular, we're talking about lines that have opposite and reciprocal slopes. Okay? Opposite and reciprocal. So if they tell us that we got this equation, y equals 2x plus 7, and they want us to write the equation for a line that is perpendicular to that one, we got to take its slope, which is 2. Same thing as saying 2 over 1. And we have to find the opposite of that and its reciprocal. So opposite numbers just means that they have different signs. So if this is a positive 2, then the slope for our line needs to be negative. There's a different color here. And reciprocal, like we said before, just means the flip or the inverse. So if we know the slope we have is 2 or 2 over 1, then we flip that to get its reciprocal. That is 1 over 2. So the slope for our line needs to be negative 1/2. Now they also say that it has to pass through this x and y value, 2, 3. And so it makes sense to write the equation in point slope form. Which looks like this. All right. So we're going to go ahead and write that. And we're going to substitute the y1, the x1, and the m with the slope that we know needs to be here, and the x and y points that we know need to be here. Okay, so the slope that we know has to be there, that's a negative 1/2. The y1 that we know has to be there, if we look at the y value for our point, is 3. And the x value that we know has to be there is 2. So y minus 3 is equal to negative 1/2 x minus 2. Number 9 asks us about a builder who used the grid to plan where to put streets in a new development. They say, the street on the grid was already there. Which of the following equation represents a line that could be a street parallel to the one on the grid? So parallel lines is kind of the opposite of perpendicular. Parallel lines are lines that have the same slope but different y-intercepts. All right, same slopes but different y-intercepts. And so the first thing we're going to have to do for this line is figure out its slope. Now the easiest way to do that, like we talked about on the graphs in number 1, is to take 2 points here. I see the y-intercept, and I see another clean point here, another clean one here, another clean one here, and we can count the change in y over change in x for any one, or the distance between any 2 of these points. So I'm going to pick the first 2, and if I go from this point here to this point here, I see that's a change of going up twice from 2 to 4. and to the right 3 times from 1 to 3. So that's 2 over 3. Okay? And so the slope that we see here is just that. Now we also want to take stock of the y-intercept we see there. When we see, and that's the first one we had, right there at, that is positive 2. So using this information, we got to figure out which one of these lines that they give us in these equations, or maybe it's multiple, could have the same slope as, or the same slope and the same y-intercept, and a different y-intercepts compared to this line that we see here. All right. So hopefully, if you're paying attention to our explanation of the last question, we see the slope of this last answer choice here, negative 2 over 3. That's opposite to the slope that we have, right? And so we know that's no good because it has to have the same exact slope. If we are looking at this next one down here, so it says negative 3x minus 2y equals 15. Let's put that into its slope-intercept form to see if we can find its slope. Now, we've practiced with it a few times. You see that if we want to solve for y to get this into its slope-intercept form, all we got to do is add the x term to both sides. And so we have negative 2y is equal to 3x plus 15. And we just divide everything by negative 2. Three x over negative 2 is negative 3 over 2x. And you see the problem right there already. 15 divided by negative 2 is negative 7.5. So in this case, neither the slope or the y-intercept, well, the y-intercept does work, but the slope doesn't work. For our slope, we need it to be exactly the same, so 2/3. So second answer choice from the bottom also doesn't work. We'll go to B. 3x minus 2y equals 14. We will do the same thing. We'll solve for y to turn this into its slope-intercept form. But this time, because it's non-negative, we're going to subtract it. We get negative 2y is equal to negative 3x plus 14. We're going to go ahead and divide everything by negative 2. We're going to end up with y is equal to negative 3 over negative 2 is positive 3 over 2x. And 14 divided by negative 2 is negative 7. So again, the problem with this is our equation doesn't quite work because we need a slope of 2 over 3. This is a slope of 3 over 2. So that only leaves answer choice A, which, unless you're trying to trick us, has to be the correct answer. But let's see why it works out that way. Negative 2x plus 3y equals 6. Okay, we're going to go ahead and get rid of that x term. In this case, we got to add it to both sides. It's going to leave us with 3y is equal to 2x plus 6. Then we're going to go ahead and divide everything by 3. Two over 3x is the result of 2x over 3. And 6 over 3 gets us to 2. So we see here that the people who made this actually made a bit of a mistake here, and let's correct them on it, okay? This is meant to be the answer to this question, right? They meant us to pick answer choice A because the test of this question is, do you know that parallel lines have the same slope? But if we believe what they tell us here, that A is the correct answer choice, then we also have to accept that the y-intercept for answer choice A is identical to the y-intercept for the line that we have here. And if we were to graph our line on this graph they give us, what we would see is we'd end up graphing our line on top of this one. Now, if we understand that parallel lines don't cross, then this situation here where our lines are overlapping, they're on top of each other, that doesn't really meet that definition. So, parallel lines have the same slope, but it's important we recognize they have different y-intercepts. Okay? So the line that we found, the answer choice A, isn't parallel to the line they already have graphed here, but instead it is a coinciding line. It overlaps the line that they gave us. All right. Number 10 says, while rock climbing, Farrell starts at 10 feet above sea level and climbs upward at a rate of 3 feet per minute. Teresa starts at 250 feet above sea level and climbs down at a rate of 2.5 feet per minute. It says which equations could be used to find the time t in minutes it takes for the two climbers to reach at the same height. So t is our variable here, and they give us these two situations, right? 2.5 feet per minute and 3 feet per minute. Now for Farrell, he climbs upward at 3 feet per minute, and for Teresa, she climbs down at 2.5 feet per minute. We should also note that Farrell starts 10 feet above sea level. And that Teresa starts at 250 feet above sea level. All right? And so using that information, we're going to go ahead and we're going to figure out how long it's going to take them to meet. Okay? And the answer choice really could be multiple of the ones we have here, right? So we got to be careful about it. So to start, I'm going to start by just modeling the situation. And so one side of this model is going to have what Farrell's got going on. And the other side is going to be about Teresa. And so Farrell is starting from 10 feet above sea level. So positive 10. And then he's going to go upward at 3 feet per minute. Yes, 3 feet per minute. And that every per conversation we had before tells us that our variable t should be attached to this. On the other side of things, Teresa is starting at 250 feet above sea level. And she is descending at a rate of 2.5 feet, again, per minute, so t. Now, if they want us to model when these two are going to be at the same height, then equal needs to be what's there. So I'm going to go ahead and drag these two a little closer. And now we have a sensical equation. 10 plus 3t needs to equal 250 minus 2.5t. Looking at our answer choices, the first one makes a ton of sense. Use green there. Now we see the only difference between the first and the second answer choice is that we have a plus here in the middle. And that doesn't work for us because that's saying that Teresa is also climbing at 2.5 feet or 2.5t upwards. So in this situation, both of the climbers are climbing upwards, which we know is not true. Eventually they would meet, but that doesn't accurately model the situation here. Okay? Now we look at the fourth answer choice and we see that 3 times t equals 2.5 times t, and that just doesn't work because there's no real number that if we multiply it by 3 and by a smaller number, 2.5, that you would get the same answer. And that equal sign tells us the answers need to be the same. So that one doesn't work either. Okay? And for this last answer choice, 3t equals 2.5t plus 10, that doesn't really work because we're mixing things around, right? The 2.5t we said was for Teresa's climbing rate, and the 10 we said was for Farrell's starting value. So both of these shouldn't be on the same side of the equation. We're going to go ahead and knock that one out too. And that just leaves us with that third answer choice, which says 3t plus 2.5t equals 240. So we're going to see if we can make our equation look like this one. And if we can, then we know for sure that's a possible answer choice. Okay. So if I'm trying to make it say 3t plus 2.5t equals 240, the easiest way I can see to do that is to add 2.5t to both sides. Now we could combine these like terms, but because they left the terms uncombined in the answer choice, we'll do the same. So 10 plus 3t plus 2.5t is equal to 250. Now we can get rid of that 10 that's there. And if we do that, we're left with 3t plus 2.5t is equal to 250 minus 10 equals 240. So as you can see, we were able to make our equation look like the one they gave us. And so we should also recognize that is a possible way to represent the scenario. All right, number 11. So we have got Lauren here who buys a jacket that is on sale for 30% off the original price. She also buys a pair of shoes that cost 1/2 the price of the jacket when it is not on sale. She spent a total of $128.40, including $8.40 in tax. They say let J represent the original price of the jacket, so they tell us what our variable is and what it represents. J is the original price of the jacket. They ask us to write an equation to represent the situation. Okay. So, they give us our variable. OG jacket price. And so we got a few different things to consider here. If they tell us that the jacket is on sale for 30% off, let me use a different color for that. We got to think about what that means. So if I have the full price, that's $100, or 100% rather, and I subtract 30%, that's going to equal the remaining 70% I still have to pay off. And this works as percentages, but it also works as decimals. 1.0 minus 0.3 equals 0.7. Okay? So here's how we're going to use that to help us in our situation here. If I know that this jacket is selling for 30% off, I know that's the same thing as saying the jacket is selling for 70% of its original price. So same thing as saying 0.7J. All right? No, I also know that she buys a pair of shoes that cost half of the price of the jacket when it wasn't on sale. So we're going to do the same thing we did before. That costs Okay? So I know that if I'm taking 100% and I'm dividing it by 2, half, that gets me 50%. And for the same reason, 1.0 divided by 2 gets me 0.5. So that's useful because if the shoes cost half the price of the original cost of the jacket, that's going to be 0.5 times J. So the jacket at 70% off plus the jacket at 50% off, which is the cost of the shoes, and then that additional $840 in tax, should be equal to $128.40. And so that's going to be the equation we write in for part A. Okay? Now for part B, it asks us to solve the equation to find J, the original price of the jacket. So we're going to take our equation, we're going to do some solving. First thing that makes sense to me here, we can add 0.7 and 0.5, and that should get us 1.2. So 1.2J plus 840 is equal to 128.40. From there, we can go ahead and we subtract 840 from both sides. And that's going to get us 1.2J equals $120. Now we can divide. And that's going to give us J is equal to 100. And so that is that. That tells us the original price of the jacket is $100 even. All right, next one. So it says, you conduct a random survey of your small town about having a town-wide garage sale. Of those surveyed, 56% are in favor and 44% are opposed. The actual percent could be 5% more or less than the acquired results. It asks us to solve an absolute value inequality to find the least and greatest percent of your town population that could be opposed to a town-wide garage sale. Okay, so because they tell us opposed specifically, we're going to be working with that 44% number, okay? So if we're writing this like an absolute value equation, right? What we know is X needs to represent the thing they told us, which is the least and greatest percent that could be opposed. And because we know this is absolute value, we're going to end up with two solutions for X. So X equals percent opposed least and greatest. Okay. And so here's how we're going to work that into our equation. We're going to say X, which is both the highest and the lowest possible score, so it's two numbers in one, minus that 44, which is the 44% that we're working with, the 44% that we see. We're going to be putting that in absolute value bars to represent both the fact that it could be the most and the least. Again, it's two numbers, so those absolute value bars help us represent that. Now, the difference they told us could be 5% more or 5% less. So whether it's higher or lower, the difference between these two numbers must be 5%. So 5 is going to go on the outside. All right? And so that equation, once it's solved, will get us where we need to go. So I know that if the absolute value of x minus 44 is 5, absolute value means how far that distance away from, or how far that number is from 0 on the number line. Absolute value is a measure of distance. So what we can do with this is consider that definition of absolute value. We can say x minus 44 is equal to 5, or x minus 44 is equal to negative 5. All right? Now, to solve in both of these situations, all we're going to do is add 44 to both sides. We're going to cancel out that. We're left with x equals 5 plus 45 is 49. Or 5 plus 44 is 49, sorry. Over here on the other side, same thing. The negative and positive 44 cancel each other out. X is equal to negative 5 plus 44. That's going to be 39. And those are our two solutions. X equals 49 and x equals 39. So the minimum percent, 39. Maximum percent, 49. Now, keeping in mind, a shortcut to this problem is taking that 44% and then just adding 5 and subtracting 5. That would also get you where you need to go. But this is how they intend you to do it, is with this absolute value equation. All right, 3 more questions. Number 13 says we got members of the track team that can run a 200 meter an average of 28.5 seconds. The fastest and slowest time is varied above the average by 2.5 seconds. They ask us to select the absolute value equation below that represents the situation. And this one's going to be a pretty easy one to knock out as long as we keep our heads about us and think about the definition of absolute value. So if we think back to the problem we did in the last question, that difference, in this case, the actual percent, the variance there, 5% higher or 5% lower, that was what ended up being at the end of our equation, right? And so for the same reason, 2.5 seconds should be at the end of this equation, which means A and C, we can eliminate both of those. That leaves us with B and with D. And I'll tell you right now the reason, or the answer, is B. Because the definition, as we said it before, for absolute value is how far a number is away from 0 on the number line. And because of that definition being the way it is, negative numbers do not make sense as solutions to absolute values, right? We wouldn't say something is negative 2.5 spaces away from 0 on the number line. We would say it's 2.5 to the left or 2.5 to the right. So D doesn't work as an answer choice because its equation would have no possible solution. There's no number you can plug in for X that would make this equation say something true. So the answer must be D. All right. 14 talks about a company that rents video games. So it says, the table shows the linear relationship between the number of games a customer can rent at one time and the monthly cost of the service. And because we know this is a linear relationship, they're telling us something in advance that means we have a constant rate of change. So if it's a linear relationship, it has a constant rate of change, all right? And so we're going to use that to help us out here. It says we've got this relationship, right? X here represents the number of games rented at one time, and Y represents the monthly cost. They ask us to write the equation they want for us in slope-intercept form. And so just like the very beginning of this video, we're looking for the slope. and the y-intercept. Now slope, as we decided before, was easy enough, right? All we got to do is track the y values, which in this case are on the bottom, over the x values. Because remember, slope is a conversation about rise over run, change in y over change in x. Our change in y at the bottom here is a change of 4. And our change in x is a change of 1. So 4 over 1 gives us the slope of 1. Or, sorry, of 4. So that's easy enough. The question becomes, how do we find the y-intercept? There's an easy way and a slightly more difficult but more versatile way to find it. We're going to use that first, and we'll go back and show you the easy way afterwards. So, if I want to find the y-intercept for a line, I have a couple of different options. The one that we're most familiar with is this. Let's just plug all the information we have into a point-slope form and then solve that for y to get it into slope-intercept form. So y minus a y value from the graph, we'll use the first one, so 14, equals our slope, which we just found to be 4, times x minus an x value from our graph. If we picked 14, then this one has to be 1, because those are paired together. All right, now we're going to go ahead and distribute to get this into slope-intercept form. Solve for y. Y minus 14 is equal to 4 times x is 4x. 4 times negative 1 is negative 4. Now we're going to finish off by adding 14 to both sides. Now y is by itself, and we get 4x, negative 4 plus 14 is positive 10. And so that is going to be the slope-intercept form for this line. Now another thing to consider, and this is the easy way to have done this, once we find the slope, we're recognizing that every time we move forward once on the x-axis, we're moving 4 places up on the y-axis. And so the opposite is also true. If we move to the left, we're subtracting 1. Moving left to the once to the left of the point that we were given puts us at 0 on the x-axis. And doing the same, moving down 4, would put us at 10. So a quick trick, if your table is as easy to jump back to the y-intercept as this one is, instead of writing it in point slope and then solving for y, you could just use the slope and count backwards. And I appreciate y'all for hanging with me here. This last one here, number 15. They say, which of the following statements are true about the function j of x equals 3x minus 4? So I'll read the statements real quick, and then we'll see if we can shortcut any of them. It says the slope is negative 4. Now, if we pay attention to the equation we're given here, we'll see that it is in its slope-intercept form, which will tell us the slope for this is this number right here. And the y-intercept is this number right here. And so if we're looking at the slope, we see that it is 3. It's not negative 4, so we can eliminate that answer choice. It says the x-intercept is 0, negative 4. Now, we see that the y-intercept is that, but we don't know for sure what the x-intercept for this equation is just by looking at it. So most likely not. Or actually, we can tell right away, because at the x-intercept, the y value is 0, not the x value. So they try to trick us here. This wouldn't be an x-intercept at all. It says the slope is 3, which we can confirm just by inspection, right? We see 3x's right there, so yes, that does work. They say the y-intercept is 0, negative 4. We can also see that by inspection, so that's good too. They ask us whether the line is increasing or if it's decreasing. The best way to figure that out is to look at the slope, and we see that it's a positive number. Positive slopes mean the line is increasing, not decreasing. And lastly, the y-intercept is at 0, 3. Now we know that the y-intercept, based on what we're looking at here, is at -4, that b value. So that cannot be correct either. So then your answer choices for this are 3, 0, -4, and the line is increasing. And that's going to be it for our little review for the first common assessment. So big idea, big concepts here that you want to pay attention to, the things that popped up over and over again. You want to make sure you're really good about the key features of linear equations. That is your slope, your intercepts. You want to make sure that you are good about solving equations, inequalities, and absolute value equations. And so maybe I put that under as well. And you want to make sure that you are good at modeling and interpreting real-world problems. Okay. So this is your kind of checklist to make sure that you're fully prepared for this CA1. I want to thank y'all for tuning into this, and happy studying.